All right, friends, we're on 8.5, sound waves. Am I on the right page? Yes. All right, take that down, please. I feel like I'm losing it. How are you guys doing? People don't respond to my check-ins, really. I'll see what that questionnaire looks like. I'm feeling fried. Sound waves. Types of sound waves. The audible range. So what you can hear, or like, if you've got good hearing, 20 hertz to 20,000 hertz. You guys ever seen that sound test online where it just keeps going, it keeps going higher, and then all of a sudden the old people can't hear it, and kids are looking around, they can all hear it, but people like me and especially Mr. Taves, anyways, can't hear it. Look it up. It's fun, nerdy stuff. So audibles between 20 hertz and 20,000 hertz, 20 kilohertz. Infrasonic, below 20. Ultrasonic, above 20 kilohertz. This kind of reminds me of visible light. Below the visible spectrum, infrared. Above or beyond, ultraviolet. Similar idea, but this is with our hearings. Oops, bang the camera, trying to be dramatic. Ultrasonic waves. Have a look. Good. Ultrasonic waves, also known as ultrasound. Oh, familiar? Can be used to diagnose and treat people. It's safer, but not as detailed as X-rays. Safer because X-rays radiate you. These sound waves reflect off or are absorbed by various tissues. The reflections produce images. They can be used to break up kidney stones or scar tissue. Have you guys ever had that, like in physiotherapy? Make some clicking kind of weird sound as they're rubbing it over your ankle or whatever. I've had it lots. Also can be used, excuse me, to measure distances in photography. A crystal is used to send out the signal and then capture the reflected echo. Ultrasonic waves. Let's get into the speed of sound, shall we? I think that's the name of a Coldplay song with the puppets. Maybe I'll include a link to that because it's one of my favorite videos. I like the song. The video's pretty great. Anyway, speed of sound. Speed is 331. I need to read this to you. 331.4 meters per second plus 0.606 meters per second per degree Celsius times temperature. The T here is temperature. Unfortunately, yeah, there's overlap. I guess there's only so many letters. But here it's temperature. Notice these weird units are so the degrees can cancel with the temperature. So you're left with just meters per second because you want speed. To use the temperature, it's in Celsius. It's dependent on density and temperature of the air. Tutorial 1, page 393. We will do that together in a few moments. Let's just do the rest of the notes. It's pretty straightforward. I think today's pretty straightforward. It's a lot of questions though. A fair amount of notes. Oh, something I just realized. I'm kind of trying to base my time on how long my recording is, but I don't factor in the time it takes to take the notes down. Okay. Anyways, take those down. Pause if you need to. Good stuff. Mach number. See, this is cool stuff. All that cool stuff you see in movies and that, it's got to come from somewhere, especially if it's real. The ratio of the airspeed of an object to the local speed of sound. So however fast something's going compared to the local speed of sound. And the local speed of sound, I would throw the page here again, but I already threw it over there, is what the formula that we just looked at. The V equals whatever it was, 331.4 plus 0.606 times temperature. That's what will be down here generally. No units. Mach is, we don't have units, kind of like mu with our coefficient of friction. We say Mach 1, Mach 2, etc. Mach 1 would mean the object is traveling at the speed of sound. Mach 2, twice the speed of sound. It's developed by Ernst Mach, an Austrian physicist. Table 1, page 395. What's there? Oh, it's kind of neat. Just look at it. I'm not even going to show you because I want you to look at it. All right. We'll do the tutorial. What is this? Oh, this is just sound intensity. Can I remember these right? Yep, we're good. Sound intensity. Sorry, I just want to look at something for 1 second. You can copy those notes down. Yeah, we're good. The P is pressure. We must combine the ideas of pressure and power to understand sound intensity. Pressure can be symbolized as P. So P is pressure, where F is force, and A is unit area. The units are watts per square meter. Loudness depends on sound intensity, which is the pressure. There's another table to look at. I wonder if there's a diagram. The cool thing about it, I'll write in something that hopefully won't bleed through, is if you think kind of like if this is your ear, or let's say this is the speaker. So it goes out like in dimensions, right? Like goes out in 3 dimensions, and so it gets wider and then wider and then wider and bigger. But this disperses it. If you're standing right here with your overly long legs, you're getting a huge chunk of it. That's where that area comes in. If you're way over here, you're getting way less. There's all this you're not getting. Here you're getting most. So that's why area matters. Hopefully that makes sense. Our hearing ranges 1 × 10⁻12 watts per meter squared to about 1. A more convenient system is the decibel, which utilizes a base 10 system. Table 2, page 395. You can look at that. We are not doing a test Thursday, I'll tell you that much. A little bit more notes here. There, good. You wrote them down. Table 3 shows how sound intensity drops over distance. That's kind of the little drawing. Where is it? Yeah, that was a little drawing that I showed you. I sketched out. This is because there's larger area of air over distance that the sound must act on. Notice how the decrease is sharper at closer proximities and much more gradual further away. Sounds greater than 100 decibels can be dangerous to your hearing if exposure lasts more than a few minutes. See table 4. I'll show you this stuff because it's kind of neat. There's your assignment, and I will do the examples for you soon. Zoom in a bit here if I can. Oh, wrong button. It's not bad, but it shows the loudness as a function of distance. Further away, the much less it is. Okay. Sound exposure. This one might be more interesting to you. 85 decibels, 8 hours, no issues. And then it goes up and up and up. 30 seconds, more than 30 seconds of 115, do some damage. I'll show you this table, even though I wanted you to look at it on your own. Maybe you guys are like, just let it go. Too bad. I'm in control. If you want, skip ahead to when I'm doing the examples. But I just think this is neat. Oh, things are falling off my camera. Sound decibel, if a jet's flying over at 300 meters, 0. Rock band, 10. Oh wait, sorry. I was like, wait, something's not right with this because there's 2 parts to this. I feel like I'm just going to do damage here trying to explain this. There we go. Threshold of human hearing is 0. I was reading it and I was like, okay, this isn't making sense. Normal breathing, 10. Whisper, 20. Empty classroom, 30. Classroom with Richie in it, 90. Just kidding. Computer, blah, blah, blah. Yeah, you can read this. The jet is 100. A rock band is 110, etc., etc. Threshold of pain, 130. That's when it hurts. Atomic bomb. I don't even want to talk about that. Already in strange times. All right. I'm going to pause it while I get my sheets ready to do the examples. But if you want to see my kids when they were like next to 0 years old, I'll show this way. That's Evan. That's Jackson. Oof. No bald spot in that picture. All right. Pausing this. All right, thought I unpaused it, talking away, realized I didn't. I wrote the units here, and then as I was writing, I realized I'm going to run out of room, so I didn't write it there. I just wanted this here as a quick reference when I use it as a formula. So that's why it's written like that. I'm trying to write big and clear and around in space. Numero uno. If the local speed of sound is 344, v equals 344. And an aircraft is flying by at 910 kilometers an hour. What is the Mach number? Oh, this is tutorial 2. I started it, so I'm going to do it, and then I'll do tutorial 1. I am sorry, you guys. This is object speed and sound speed. Okay, so this is the speed of sound. Speed of sound. Speed of the object is 910 kilometers an hour equals 910 kilometers an hour. I usually don't write the units here because, well, it's just time. I have a marker all over my fingers. But this is kilometers an hour. We need to put it in meters per second, okay? To be able to do this, we need to put this in meters per second. Now, 910 kilometers an hour, let's write it here. Kilometers, that's 1,000 meters, right? So it's 910,000 meters per hour. An hour has 60 times 60, 3,600 seconds. So 910 kilometers an hour is 910 divided by 3,600, 252.8. This is 1,000. We multiplied 910 over 1 times 1,000 over 3,600. That 1,000 over 3,600, that's still on screen. That's 1 over 3.6. So if you don't want to like think your way through this, if you want to memorize something, divide this 910 divided by 3.6. If you're going from meters per second to kilometers an hour, you can multiply by 3.6. Okay? So anyways, we got our meters per second here. This question is asking what the Mach number is. Yeah, so m equals this. M equals, the object speed is 252.8, or 7 repeating, over speed of sound 344. So this, it's already in there, divided by, I love it when that happens, 344 equals 0.73. How many sig figs in this question? 2. The Mach number is 0.73, so it's 73% of the speed of sound. That's how fast this aircraft is going. Mach 0.73 doesn't really make it into James Bond movies, but that's what it is. Okay, I'm going to try and do the next question on the same page. Number 2, if the Mach number is 0.93, m equals 0.93, and the local speed of sound is 320, vs equals 320, what's the speed of an airplane in these conditions? I like that, in these conditions. So Mach is 0.93. The number on top is the object. I'm just going to call it x, not o, because that looks like a 0. Over speed of sound is 320. 320 times 0.93, right? Multiply both sides by 0.93. I mean by 320. 320 times 0.93. So the object speed is 297.6, which is, how many sig figs? 2 sig figs. So that's going to round to 300. So it's going to be 3.0 times 10 to the 2 meters per second. Did it ask for, oh, you know what? Okay, so it didn't ask for kilometers an hour. It just gave it in both. So let's figure this out in kilometers per hour if we wanted to. Remember, we divide to get to meters per second. We multiply to get to kilometers an hour. So I'm going to multiply this number by 3.6. And that equals 1071.36 kilometers per hour. But again, we want 2 sig figs. That'll be 1100. So that equals 1100 kilometers per hour. Or if you wanted 1.1 times 10 to the 123 kilometers per hour. So we have our two solutions. Those are both the same. Does that make sense? I think it's relatively straightforward. While I'm writing up the next question, because you know that this is the last, I won't talk and do two things at the same time. I'll talk at the end. Number 3. Mach number is 0.81. M equals 0.81. Speed of the airplane measured by radar is 850. So V of the object equals 850 kilometers per hour, which 850 divided by 3.6 is 236.1 repeating. 236.1 repeating meters per second. What's the local speed of sound in kilometers per hour? Okay, it wants kilometers per hour. So we have 0.81 equals 236.1 over x. 236.1 divided by 0.81. Right, you just switch these two. 291 x equals 291.495. Let me check the sig figs on this bad boy. Oh, this is only meters per second anyway. Okay, so this is meters per second. It wants it in kilometers an hour. So the velocity of speed of sound, the velocity of sound is going to be this, 291.495 times 3.6. 291.495 times 3.6 is 1049. Decimals aren't going to matter because we're going to have to do some rounding. How many sig figs is 2 sig figs? This rounds to 1,000, right, for 2 sig figs, which, if we want to show our sig figs properly, 1.0 times 10 to the 123 kilometers per hour. All right, before I do tutorial 1, because it's backwards day, sorry guys. Before I do tutorial 1, I want you to think, are these tests, the way we're doing the evaluations, are they working for you? Because I am marking constantly. I'm marking constantly. I have other parts of my job I need to do, and I wanted to start the pre-cal tests today. I got through 2 so far, and it's 4:20, and after this I'm gonna record the pre-cal lesson, and then I'm gonna keep marking. So if you guys can think of a better way, I'm all ears, friends. I'm all ears. Okay, anyways, let's move on to the next one. This is practice 1. Page 393. Sorry about doing this reverse order. Really, I don't think it really matters. Question number 1 says, if the temperature of the air in your region is 32 degrees, so T equals 32, so it's warm, what is the speed of sound in the air at that temperature? So our formula, V equals 331.4 plus 0.606 times T. It's pretty straightforward, right? V equals, so it's going to be 0.606 times 32. I'll do all the steps. 0.606 times what? Times 32. 19.392 plus 19.392 plus 331.4, 350.792, 350.792 2 sig figs, 350 meters per second. Oh, textbook gave 3 sig figs. That was dumb. Textbook made a mistake. 350 meters a second. It wasn't dumb. I shouldn't say that. They just made a mistake. Number 2, if the speed of sound near you is 333, so V equals 333. What's temperature, right? What is the ambient temperature? Now notice this is 3 sig figs because this is the only measure they've given us. It's going to be 3 sig figs. All right, so this whole equation is written again, right? And then we put in 333 for the V. 333 equals 331.4 plus 0.606 T. So we're going to have to subtract this and then divide that. 331 divided, or sorry, subtract minus 331.4. 0.606. Now we're going to do both sides divided by 0.606. 2.64. That is the temperature. I'm going to take a gamble and try and get question number 3 on this. Then we're done. 3 says the speed of sound near you is 350. What's the temperature? What's the ambient temperature? Yep. Notice 2 sig figs. V equals 331.4 plus 0.606 times T. V is 350. 331.4 plus 0.606 times T. This question is the same as last one, except it's got 2 sig figs. 350 minus 331.4, 18.6 equals 0.606 T. Now we divide both sides by 0.606. 30.69. Oh, we want 2 sig figs, right? Yeah, so it's going to be, 31. Phew. Does that jive with what the book says? Yes. Yes. Okay, so that was over half an hour with you know, if you guys taking down notes and such. Let's say whatever the assignment was, it's here somewhere. I don't know. I don't know how much is too much time. I don't know how much is too little time. I want to say, like, do you need extra time with this? Today's Tuesday. What day is today? No, today's Monday. Yeah, but I'm recording this for Tuesday. So this is a Tuesday assignment. Let's say I give you Tuesday and I'll give you Thursday. Okay? Friday we talk evaluations and such. If you want, look at 8.6. Which normally would have been assigned if we were in school. But just look at it. It's interesting, I think. Read about it. If you don't want to, you don't have to. But I'll give you Tuesday and Thursday to do this, because Wednesday's not like anything assigned. I might pick your brains on Wednesday about how to evaluate. If you guys are happy doing this, then yeah, so be it. I'm getting tired of marking. I'll try and figure out a way to streamline and help you guys to make it easier for me, maybe. I don't know. Am I being selfish? I don't know. I'm talking to a screen. All right, take care. How do I stop recording? What the? Oh, there it is. Okay, bye.